This is antenna training lab model ATS20 receiver. Now as you can see, it again consists of a PLL synthesized receiver ranging from 5 MHz to 2000 MHz, similar to the frequency of transmitter, and it has RF in block, down converter and up converter block. Right now the LED is glowing in the range 861 to 2000 MHz because frequency on display has been selected in this range. As you can see, it is 1500 MHz. The output from 48 to 860 MHz is available at RF in at SMA connector, and frequency in the range of 861 to 2 GHz can be received at down converter input in this range using this block, and similarly frequency 5 to 47 MHz is available at this input at up converter block. Now as you can see, it again has the same 5 controls: up, down, escape, menu, enter, for selecting or changing the frequency or changing the step size. It has a demodulation block which consists of a demodulated output, RS232 connector where the antenna plot is stored in the memory locations of the receiver, a volume for listening to the demodulated output or any FM station. Now as you can see, there is a trigger inputs. TX means the pulse from the transmitter can be connected here using a BNC cable provided, so that transmitter and receiver works in synchronization in auto mode. Stepper input, where it is connected to stepper input and the trigger output from stepper feeds into the stepper, and in respective locations of the memory, the plotting or the received signal strength can be stored. RSSI stands for received signal strength. It is a detected output in DC volts which can be viewed using a multimeter. Similarly, there is an IF output where IF frequency is available, a very low frequency, which can be connected to any 500 MHz spectrum analyzer externally. Now we come to the display. As you can see, it is displaying FREQ, which stands for frequency. It is displaying 1500.00 MHz, and this block is functional so that the input can be available here. As you can see, if we connect RF input to output here using this small pigtail cable SMA to SMA, this input can be connected to tripod or an antenna, and it will be able to receive the signal in the range of 1.5 GHz. Now as you can see, it is showing a memory of 0001, that is the first memory. M stands for manual. It can be changed from M to A, which A stands for auto mode, and right now it is displaying a signal strength of 11.2 dB microvolts. This reading can be changed to dBm or picowatt or nanowatt depending upon the customer's requirement, whether he wants to measure the power in linear range or in logarithmic units. Normally for plotting we will use dB microvolt, which is a positive scale. Now as you can see, if we press the up key, the frequency will change in the selected step size. As you can see, the step size is 10 MHz, so it is changing in 10 MHz step. If we press the menu key, the memory locations are blinking. Now the manual or auto mode can be selected. Pressing the menu 3 times, the display of step size is available. As you can see, the maximum step size of 100 MHz, minimum 50 kHz, 0.1 MHz, 0.25, 0.5, 1, 10, 100. So these step sizes are also available at the transmitter end. Pressing the menu 4 times, you can see if we have stored any memory, that frequency and level would be available. And pressing the menu 5 times, it says serial mode equal to yes. If we press enter, Suppose we have taken a plot, we will discuss it later also. The output is available at this RS232 end, which is again connected to a computer with a polar plotting software provided. The data will be dumped. The entire 1000 locations will be dumped into the PC using this RS232 connector. Now pressing the menu 6 times, now it shows the received signal strength or the power. Now it is dB microvolt. Here it is dBm. So 11 dB microvolt was roughly equal to minus 96 dBm. This is the noise flow. Similarly, there is a dB relative unit. If we want to have the comparative gains of antenna in dB relative volt, now it shows the power in picowatts, around 0.26 picowatts. So we'll bring it back to dB microvolt and press enter. Pressing the enter key will select the blinking mode. Now, as we have already discussed, pressing the menu 3 times will select the step size. Now in 5 MHz mode, the output is available at up converter block RF input, and the cable has to be connected from RF in block to up converter, and this can be connected to tripod. And similarly for ranges in 48 to 860 MHz, the output is available directly at SMA connector and antenna can be connected directly here.